Good afternoon, everyone. Welcome. I'm Marc Parlange. I've seen this film a few times now this past year, and I have to say it's still a delight to look at. So I'm Dean of the Faculty of Applied Science, and a warm welcome to UBC this afternoon. It's an honor to host this talk together on the future of robotics with none other than Professor Elizabeth Croft, who's a friend and colleague and professor in mechanical engineering and Associate Dean for Education and Professional Development in our faculty. I'm delighted to welcome you to this beautiful building. This is the Robert H. Lee Alumni Center, and it opened its doors in September. And I think we have all really enjoyed having it here for lots of reasons. But I would also like to acknowledge that we are on the traditional, ancestral, and unceded territory of the Musqueam First Nation. We want to acknowledge the estate of Kitty Heller for their generous contribution to making these talks possible here today at UBC100. What's next? Also, I would like to thank our affinity partners TD Insurance, Malak Monix, Manulife, and Worldwide Quest, and to our media partners, the Georgia Strait, the Taï, Vancity Buzz, and Glacier Media. Thank you all. As you just watched in our centennial video, and I should mention that the Faculty of Applied Science was one of the 3 founding faculties at UBC, we're really proud to mark this 100th anniversary as a global leader in education and research at UBC. Our year-long celebrations have been much about the future, as has been the past, of course, and those first 40 UBC graduates in 1916 were probably thinking more about the future than they were thinking about the past. And today's talks really try to look and ask the important question, where are we going and how are we going to get there? And as Elizabeth reminded me, at some level, whatever she says today, there's not too many of us that will be around in 100 years' time to actually hold her to all the predictions. But I think you're going to find that it'll be excellent. So today's events are also, you'll also notice that we have graduation going on, and in September 1915, UBC welcomed 379 students, and over the past century, we've graduated more than 310,000 students from our Point Grey and Okanagan campuses, and all these people have gone on to make magnificent advances and change in British Columbia, Canada, and around the world. And so we are delighted to have so many of our graduates here today. Now, at this point, we usually have a formality where we ask you to turn off your cell phone, but apparently today we don't want you to do that. What we would like you to do is, well, actually, I'm reminded you can put them on silent, but we would like you to tweet the event at alumni UBC, and the hashtag is hashtag UBC100. And so that's, I think that's there. And so this afternoon, we would also like to have a little bit of engagement in, we'll do the classic engagement question and answer, but we're also going to have a chance to do engagement and have a conversation. So if you have a mobile device, a smartphone, a tablet, a laptop, take 30 seconds now. Please take out your device and go to, and there is this address, alumniubc.cnf.io. And so the URL is being projected now to give you 30 seconds. So while you're doing that, maybe I'll talk a little bit. So this, the idea will, this audience engagement platform will allow you to ask questions and comment in real time throughout the presentation. And then other attendees can like your question, and following Elizabeth's presentation, I will sit down with her up here and we will pose some of the top questions during our Q&A. So again, the URL is alumniubc.cnf.io. Is it good? Everybody's there? Okay, good. So we're going to make a trial run. So it's always good to have a little test. So we are going to, we have a polling question. So let me see if I can also pull it up. And so do you all see the polling question? And the question is, are you a UBC alumnus? So if you can vote. Actually, let me ask an old-fashioned way. How many of you are future UBC students? I know there are at least, great. You're all going to study engineering, I hope? Okay, very good. Okay, so let's see. I'm going to, the results of the poll will be projected on the screen. They're coming up. So I don't have my glasses on. So is blue, which way does it go? Yes, is yellow. So we're more than 50%. Welcome everybody today. I'm delighted that you're here. Okay, so please add your questions during Elizabeth's presentation, and I'll be keeping track on my tablet. Now let's get started. So it's really, as I mentioned, it's a delight to have today's speaker, Elizabeth Croft. She's a world leader really in the area of human-computer interactions. And this is a hot area today, but as you can imagine, it's going to become more and more increasingly important in the coming years. The tools are obviously going to change, but the problems such as how do people and robots get along will remain the same. Questions surrounding what robots should do, how we can share, operate safely, communicate, take turns, teach robots, and generally get along together will continue to be problems requiring solutions. The efforts we make to establish the rules of engagement now will be fundamental to our future relationships. So it's my great pleasure to introduce Professor Elizabeth Croft. Elizabeth is a UBC alumna. She's Professor of Mechanical Engineering and Associate Dean Education and Professional Development in the Faculty of Applied Science. She's Director of the Collaborative Advanced Robotics and Intelligent Systems Laboratory, and her research investigates how robotic systems can behave and be perceived to behave in a safe, predictable, and helpful manner, and how people interact with and understand robotic systems. She has received numerous academic and community awards, all extremely well-deserved in engineering, as well as WXN's Top 100 Most Powerful Women in Canada. And so please join me in welcoming Elizabeth Croft to the stage.
Great. Thanks, Marc. Okay, thank you very much for that very kind introduction, Marc. It's a real pleasure to be here. I am a UBC alum, and I see many friends, colleagues, people that I've known for a long time here in this audience. So you're making me a little nervous, but I'm going to be good with it. So yeah, in 100 years, what is it going to be like? I won't be around, I'm pretty sure. Maybe some of you won't be around either. And some of our robots that we're building and thinking about today will outlive us. But there will be robots everywhere, I can guarantee you that. And one of the questions we want to ask today, as we do our research, as we think about this, is what will those robots be like? And that will depend on the work that we do today. Just so we have some grounding, I do like to have my right epistemology. What is a robot? So the first use of the word robot was in a play by a Polish author by the name of Karl Čapek, and he defined these robota as artificial workers that were used for forced labor. They were a kind of serf in the play that he wrote. Reprogrammability is a part of robotics. Often people think of robots as being humanoid. That's not necessarily the case in many of the robot applications, but it's often a thought that people have about robots. I like to think of robots as embodied intelligence. So we have computers now, like Watson, these big data systems that can think, but the difference between sort of computer intelligence, artificial intelligence, and robots is the embodiment, the ability for a device to physically interact with the world and change it, which also allows those devices to physically interact with us. And that's sort of where I position robotics and the difference between AI and robotics, although they're very tightly coupled. So what do we imagine robots will be? Well, growing up as a kid, Rosie the robot was absolutely one of my favorite characters, and I did want a Rosie. I also, as a teenager, really liked Terminator. But what I do see and what I hope for as a future is in probably more the friendly kind than the dystopian kind of robot. But the questions are, how do we get to these futures? What will that be? And how will we get along? So this is actually one of my favorite cartoons, XKCD, and it's about Isaac Asimov's 3 rules, which are basically don't harm others, or don't harm humans, obey orders, and then protect yourself. And so if it's in that order, things go well. If we move those out of orders, we either get a frustrating world, a killbot hellscape, or a terrifying standoff. None of those are good. So really, there are some important rules about getting along with robots. And that's some of the work that I will be talking to you about today in how things are going to evolve in the future. But what we need to know now is, what are these enablers? How are we going to get to the future? And those enablers are basically the brains of the robot, computational power, the thoughts of the robot, machine learning, the connections, the ubiquity of being connected into the world through the internet and through this community of internet, which we call Internet 4.0 or the Internet of Things. We need unplugged power for robots to wander around the Earth. We need something called open, and that's open software, open hardware, maker, the ability now for people to create their own robots. The combination of all of those things, these are pieces that we have right now, will drive our robot of the future. So what is this about computational power? Well, I'm sure you may have heard about quantum computing. It's a project that can exist and doesn't exist at the same time, maybe. No, actually, it is a real thing. And what's very, very exciting about quantum computing is it takes us up this curve. So that curve you see right there is Moore's law. And it's the fact that we are continuing to double the computing power we have year after year. And where we're going right now is continuing because of the opportunity for advanced computing like quantum computing. And what's really interesting and exciting about living in Vancouver is there are only 3 companies in the marketplace right now that are doing quantum computing, and one of them is D-Wave, which is in Burnaby, and it is involved with people that are from UBC are involved. Our own students who are graduating from our programs right now are working at this company. So that ability to be able to solve look at many problems all at the same time through these qubits, this ability to represent many things all at the same time, and then come to the minimum and the optimal solution very, very quickly is incredible. And that will, again, jump us forward in that computational power. And then there's the thoughts. Well, if you have this power, this ability, this brain, what is the thinking behind that? And so that is machine learning. And that is the opportunity to look at data all over the internet, to look at these different types of databases, whether it's a database about images, right? You go on Google Images, and there's thousands and thousands of labeled images. And those images can be used by a robot to say, I see this thing. I'll go Google Images. Oh, look, I can match that. That is an apple, or that is a cereal box. So we have this ability to search the information of the internet and be able to use that to do basically matching, to learn what different things are in the environment. So machine learning is part of those thoughts. And what's really interesting is that we've got to the point with Watson, which is IBM's deep learning system, that recently at Georgia Tech, one of the TAs in the comp sci course was a robot. Okay, so they had a group of 9 TAs, and one of them who was answering questions online for students was actually Jill Watson, not a human being, basically an algorithm built out of the Wall Street Journal. I'm sorry, not the Wall Street, built out of IBM's Watson. So what we see, which is exciting, is that it actually passed the Turing tests, the test that allows us to see whether a device could substitute for human. And then there's the connectivity. So the world, in a sense, according to the definition that I gave you about being able to have embodied intelligence and being able to interact with the environment, is a robot. Okay? We have many, many things connected across the environment. There is intelligence out there, and there's the ability to act and connect with devices. And the conversation, the things that are happening, is that we are coming to common protocols, common ways of communicating across the internet over a wide range of computers, sensors, machines, and storage systems, which will allow us to be able to build a worldwide robot. So maybe the robot isn't the Terminator, maybe the robot isn't Rosie the robot, maybe the robot is Internet 4.0 and this collection of all these devices that interact in the environment. And it's growing. And that's what's really remarkable, is the amount of things that are connected to the internet is once again growing on this exponential curve, where we see, right, 2016, we're here right now, because this is a 2012 report, we are seeing increases, vast increases in this conversation that's going on between devices everywhere. The other thing that robots need to be able to be successful is they need power. They're incredibly power-hungry devices. I have a robot, his or her name is Charlie, depending on how he or she is feeling. Needs a lot of power. Charlie runs on about 4 car batteries and lasts for about an hour, hour and a half before Charlie needs to charge up again. But what we do need, and what's going to allow us to have robots that roam around the world, is the ability to densely store power. That blue arrow there points to one of the most dense power storages we have right now, which we all carry around, which is fat. Okay, so the fat in our body allows us to be very efficient and to move and to store that power and then to utilize it. And it's great because you can just kind of pick up a power bar on the way and then recharge, right? So whereas lithium-ion batteries and car batteries, which we're using right now, are down in that bottom left corner. So as you can see, that is actually one of the key technologies that we're going to have to advance, power density and power storage, in order for us to advance robotics. And robots need to be able to talk to each other, not only on wired connections, so the fiber optic connections of the internet, but also while they're roaming around in space. And right now, there are more than 500 million wireless devices out there in the environment. And in terms of communications that are going on, it's at about 21.7 exabytes. That's a 1 and 18 zeros, which is a heck of a lot of zeros of information being shared in wireless right now. So that's another enabling technology, the ability basically for robots to run around the world and talk to other devices. The next big piece, open. What do I mean by open? Open computing. The fact that Linux is now an operating system that you can use on your own computer that competes with the Microsoft Office system and other operating systems. The fact that there's something called ROS, Robot Operating System. Some of you probably remember DOS, Disk Operating System, File Not Found. Okay. So ROS is Robot Operating System. We're now into K, so we've gone through many generations. This is the open operating system that many new robots are operating on, and it's to the point where big manufacturers like ABB and KUKA and Hyundai, the big manufacturers of robots that are sold around the world, are starting to recognize that this is a competitive technology. And this is actually basically a Silicon Valley startup that's gone open, and it's being contributed to by graduate students and researchers, and even undergraduate students working on projects are able to download this software, use it to control their robot, and then when they make a change, upload it and show other people how they can share. So it's this open community of creative people working on ROS. There's open robot operating system. There's an open computer vision, OpenCV. There's maker robots like QB Robotics, and I'll show you a bit of that. And then we have an initiative right here at UBC that I'll tell you about, which is the Open Robo Ethics Initiative, which is a collective thinking about those important questions about how robots should get along and letting everybody contribute. And that's what makes the difference. So this is, there we go. This is a first example of an open robot. You can buy the plans for all the links for this robot, download it, print it, and make your own robot. And it's available just on the online as a web thing. So if we can go to the next slide, the rest of it is a lot of Italian talking. Maker. This is a big part of it too. Not only is the ability now to print your own robot. So this is a 3D printer, a MakerBot. It's printing basically the head, the face of a robot. And as you can see from the graph, again, that exponential curve of the ability of desktop printers that are being used by people around the world. So we've got so many different pieces here. We've got the computation, we've got the communication, we've got upcoming power, and we've got this ability, this open ability to make your own robot. And those are the pieces that are pushing it forward. In fact, we even have biomakers. So this is UBC technology. This is Conrad Wallace's 3D bioprinting. This is a professor in electrical engineering here at UBC who is actually able to produce and print tissue. That's incredible because now you're not only able to make the brains that can communicate, but you can create a biological piece that can connect into robotic devices. So that's pretty exciting, a little scary too. So what will this mashup look like? I hope it's rosy. And I want to show you a video from, this is from the German Center for Robotics that I visited earlier this year. So I like to point out that the robot is using a vacuum cleaner to clean up after itself. Okay, and it is able to sense, grasp the handle of the robot, of the drill, and then hopefully we're going to see it be able to, it's found that drill. It has to do a little thinking here. Okay. And now drill a hole through a concrete block because those are the kinds of things that we like to do with robots. I'm not really sure why this demo, actually I do know. It's because the ability to go from no force to maximum force and then to sense when the robot has gone through the concrete and not keep pushing along is all embedded in the intelligence of this robot. So you can see we're actually getting close to all of those pieces, and I just love the fact that it cleaned up after itself when it was done. Okay, if we could move on. So here we are today, and we're still with our robots. They're not very humanoid. They're actually in lonely colonies building cars for us at the GM plant. And we'd like to get them together. We'd like to have people and robots working in collaboration. We'd like to get a robot hug, me and Charlie. We'd like to be able to take the end of the robot and be able to help it help us. But we need to figure out whether we're going to have conflict or we're going to have collaboration. So one of the things that we're thinking here at UBC is about how we share space with robots. When we get together and we're both reaching for something, if I'm reaching, ooh, how did that happen? If I'm reaching for a salt shaker, a knife, and you're reaching for something, how do we resolve that conflict? So Ajung, who's one of our PhD students, sorted out that it's actually when we both reach for something, we use something called a cue called hesitation. We use that to communicate to each other that I recognize that you are there and I want to mediate a solution with you. So we use human cues to collaborate. And what we're thinking about is how we can use those cues to collaborate with robots. So what we developed in the lab with Ajung is designing gesture trajectories that mimic human hesitation, that allow the robot to show that it recognizes you're there and the user perceives that hesitation. So we have the worker, the robot assistant, and a shared part spin that they're both going after. So if we can fire that video. So we show 3 examples. This is traditional robotics without collision avoidance. Oh, can we go back? There we go. Thanks. So here's traditional, blind condition. The robot doesn't know you're there. And this is what it looks like. Not so good. Okay. Then if we go to our next condition, I'll just give it a minute here. Oh, get your hand out of the way, Adrian. That's not good. This is traditional collision avoidance. The robot recognizes that the person's there, but then it stops. So the user is not quite sure what's going on in that collision avoidance scenario. And people liked it when we did tests with users, but they were very confused. Then we implemented this hesitation gesture, this little cue that says, I recognize you're there. So when the robot sees that the worker's in the way, it does a little bob that users interpreted. They looked at it and they said, oh, the robot knows that I'm there and it's giving way to me. What a nice robot. This is the kind of robot I'd like to work with. They thought it was shy. They thought it was kind of cute. So it's interesting that just these little hesitation gestures added a bit of humanity to the robot. The other things we're going to have to do with robots is we're going to have to share. Robots can be very, very grabby. They tend to hang on things really, really hard. And what we worked on is human-robot handover, teaching robots how to pass objects nicely. So this is work done by one of our students, Wesley Chan. If we can slide back for a minute. What this work was done is we made this little tool here. It's actually a handover baton. And basically, it measures forces and positions of where that device is. So it was created in the lab. And we brought people in, and we got them to hand it over hundreds and hundreds of times, back and forth. And what we discovered is there are rules for handover, and we better teach them to robots. And those rules are that the giver is responsible for the safety of the object. The receiver is responsible for how fast that handover takes. And that's natural. And somehow we've already figured that out, and we hand stuff over, and most of the time we don't drop it. So what we did is we taught the robot those rules by designing a controller for the robot to give things and be responsible for safety. So in this video, here we go. Oh, can you go back? There we go. And start. I can do robots, I just have technical difficulties. There we go. Excellent. Okay. So this is Wes, and this is Charlie, and this is the traditional handover with Charlie. He's very grabby, and when you push him around, he drops things. Not good. So the controller that Wes developed basically allows the robot to recognize when things are being taken from it and only let go when things are being taken, not when the arm is being displaced. So it measures the grip force and the load force, and it only lets go when Wesley is taking things away from him. The real value here is when you're handing over a hot cup of coffee and there isn't a tug of war. Okay, so what else do we need? Well, imagine that we're going to have a robot working in a factory with us. So we have a robot that's going to be able to fetch things, hand things over. What's that going to look like? So we took some of these ideas of sharing, space understanding, collision avoidance, and we put them together in a car door assembly operation. So this is one of our students, Matt Pan. He's currently doing an internship at Disney, so we miss him a lot. But here he is working with a car door, and we've got a robot that's got the handover algorithm, collision avoidance, position recognition, and it's fetching parts in our high-tech part slot there that we made out of the cardboard box. And it's bringing this part over to Matt while recognizing that Matt is working. So it stops until Matt comes over, recognizes that it's being repositioned, and then when Matt gets the part into the right place, just lets go nicely, and there's no tug of war, and then recognizes again what Matt's gone back to do and realizes it needs to go back and get another part. So this is the first step of what we think is going to be the assistant of the future, something that's paying attention to you, hopefully helpful, shares space, hands over things nicely, and is, after all, kind of cool in an orange kind of way. All right, so let's move over from there, because Matt tends to talk a lot, and talk about the future, those rules of engagement. So Asimov's rules actually had a zero rule added to it, which is don't harm humanity, right? Or through inaction, allow humanity to come to harm. And then the 1, 2, 3, don't harm people, obey orders, and then protect its own existence. And in that order, for those very good reasons of having things turn out well. How do we think about those rules? And does everybody agree on those rules? Well, through a project that we call ORI, or the Open Robo Ethics Initiative, we've gathered people from law, from ethics, people from universities across the world to think about these problems. And what we do is we create questions that we want to ask the general public so that we can, in an open way, source what people think about important questions about how engineers should design robots and what should be those rules which form the base of the algorithms that our robots will use. So one of the most recent surveys we did was on the ethics and governance of lethal autonomous weapon systems. So these are robots that can potentially, can't violate Asimov's law. And how do people think about this kind of, activity, and what should roboethicists and roboticists do in terms of programming robots? So, oops, I didn't mean to go there. Are we going to fire that video? Oh yeah, it's a link. Can you play the link? It's on the, click on the logo. Oh dear. Uh-oh. Okay. That's all right. Okay. Just keep going? Okay. All right, so when we did, so I'm going to invite you to come and, sorry? Oh, sorry, is it the picture? Click on the picture. Oh, okay. My bad. I forgot to test that one. Okay, so you'll just have to Google ORI, and you'll see the video that talks about the ethics and governance of lethal autonomous weapon systems. So we asked some questions. People are comfortable with war systems, robot war systems, when people are in control. When they're not, when they're really basically someone making a decision behind the robot. They're much more comfortable with that. But no matter who you ask, from whichever country we asked, and we asked for like 27 different countries where we translated the language so that we got input from a wide range of people, people are overwhelmingly uncomfortable with lethal autonomous weapon systems that make decisions for themselves. So it's really quite clear that when we think about designing robots, we still have to have people in charge. That those laws of Asimov, of don't harm humans, actually really should embed the underlying design of our code. That we are entering a world in which we can create robots that can do great good or create great harm, but they are going to come. Roboticization of our environment is going to happen. And we have to be very careful about the rules of engagement that we use. And there's the video. Look at that. So welcome to my lab. Can we turn the volume up? There's Charlie and Ajahn. Oh, sorry. Okay.
To our homes and workplaces to interact with us. And we wanted to look at the public sentiment when it comes to the issue of lethal autonomous weapon systems. Today, we're very familiar with the idea of drones being used for war, which are what we call remotely operated weapon systems. So you have these flying robots that essentially act as eyes for the pilots who are in a different location, controlling the robots, and making that lethal fire decisions. Now imagine taking that human out of the loop so that there's no human behind the cameras, but it's the robot or the autonomous weapon system that is surveying the area and picking out what is a legitimate target and making that fire decision on its own. That particular system is what we call lethal autonomous weapon systems. When it comes to reasoning about this particular lethal autonomous weapon systems compared to remotely operated weapon systems, people tend to have a very shared principle perspective that machines should not be making life or death decisions in place of humans. And the fact that it was shared across different cultures or different countries was very interesting, because that means there is something that we need to be really concerned about in terms of the moral challenge that we're facing in developing and implementing or deploying this particular technology.
So it's important, I think, as engineers, as researchers, as Ajahn said, that we pay attention to this and we ask these questions now, because as we see, the technology is coming, and it's important that we think about how we want to have that play out. So, but I do hope that in the end, it's going to be rosy, not Terminator. So I think that's really, not to end on a sad note, but on an important note, what we need to think about the next 100 years, about the future of robotics. And at this point, I think it's time for Marc and I to answer any questions you would have.
So thanks, Elizabeth, for a very thought-provoking talk. That was fantastic. It was special. So we have a whole bunch of questions, and I'm going to ask a couple from the audience and from colleagues online. And so the first, well, there's actually, well, I see one actually, number 4. This is just a quickie because I think I know the answer, but a group want to know, are you Charlie?
No, Charlie is a PR2 robot. Unfortunately, we weren't able to. Charlie's not an indoor robot, not an outdoor robot, and it is pouring wet rain today, so I wasn't able to bring Charlie with me. But in that last video, you saw my graduate student adjunct with a robot, and that is Charlie.
Okay, okay. So the first very interesting question is, can robots develop consciousness, and can they form their own morality?
Okay, so that's a important question to think about. I will not say no, because I know that if you say no, it'll happen.
Yeah.
I think that we're getting to a place where robots can, through learning and through AI, come up with an evaluation of its sense of embodiment, the fact that where it is, what it is, have knowledge. So if that is consciousness, if that is the ability to describe yourself, then I think actually we're already there. Morality, now there's an important question. And I would say that is about rules. Okay, really we hook our morality to rules, whether those are Asimov rules or the Ten Commandments or the Koran or whatever set of rules you are. We as a society have actually got sets of rules. You know, we're nice to each other. We don't run with scissors. We have the golden rule. We treat other people like we want to be treated, and we train our children to take on those rules, and we say that we value them. So in the sense of programming robots, which are programmed by rules, we can certainly do that already. And whether they can generate new rules for themselves, very, very possible, because they can reason based on the existing rules. So it's all there.
Maybe a related question, which tied also for first, do robots have the potential to rewrite their own code?
Absolutely. That's the ability to regenerate code from existing code. That's already a thing, people. Unfortunately, well, or fortunately, I mean, it's exciting in both ways. And that's why it's really important, again, I think, to start thinking about the rules of engagement, about what we want robots to do and not do.
Okay. I would like to ask one more question from the list, because it's an interesting one that I think is, and then we will go. I understand there are people with microphones, so you can put up your hands to ask questions, and then our colleagues will join you. But as a parent, Elizabeth, is raising a robot similar to raising a child? Teaching how to share, etc.
I am inspired by my children. I think they've certainly influenced in a great deal how I think about robots. I remember when my kids were little, and they're doing those puzzles. You put the shapes inside the wooden thing, and you'd want to put your hand on top of them and show them how to do that. And that really inspired a lot of the ways that I work with robots. Is that they're kind of like little kids. Of course, little kids are way smarter still and a lot more fun. But in some ways, they're really the same. Like, you know, when the power drops on kids, they just go flat on the floor, and that's the same with robots.
Okay, that's great. So do we have a question from the audience? If anybody would like to raise their hand. Yes, please. We have two here.
It's really interesting. I'm wondering if there's a global, like a steering committee or something that there is.
So there certainly is a global, at the UN, there's a global committee looking at this, and Adjung has been presenting at the UN on some of the work that she has been doing as part of the ORI initiative. There is also a global collective called No Killer Robots. I'm a member. And so there are a lot of people. There's also a collective, a law and robot ethics collective looking at these issues. So there's a lot of different groups that are very, very concerned, and rightly so, on the rules of engagement.
Thank you. Yes, please.
I'm not a robotics person, but I'm very curious. If robots can rewrite their own code and make their own moral judgments, develop them, how do we set limits?
Well, I think, so when I say rewrite their own code, they can just generate lines of code, right? They can now generate, you can write an algorithm that generates an algorithm. The morals that they have right now are the rules that we set down, right? So we're still, right now, in control. And we can still unplug them, which is great. So what I'm saying is that when we think about how we program robots and when we think about sort of the base code that then they can work off of, we can also set limits, right? We already set limits on the power of actuators. We already set limits on all sorts of different capacities that the robot has. We can also set limits on how much information they can access and when they can access that information and what information they can give. Similar to your kid when you limit their internet time, right? So there are things that we can do, but we need to be very intentional about what those decisions that we're going to make, because the technology is moving very, very quickly. And it is possible for it to overleap our bounds of putting those limits on it.
Maybe a related question, a very popular question as well. Will one day robots or a robot take over the world?
I think I'm always optimistic. I think we will figure it out. I don't think that robots will take over the world, but I do think we already see with the Internet of Things that there's a lot that is being done robotically, in a sense, that sometimes goes beyond our control. And I'll give you an example. A few years ago, remember when the power outages in the East Coast, and they started in one power plant, and then they went on from power plant to power plant? That was all based on autonomous systems that were making decisions with no human in the loop. And they were making decisions about, okay, where to go to keep the system up. They're following a rule, which was keep the system up. But they weren't following the rule of, well, worry about other people's systems as well. So they were taking power away from other systems that brought them down. So they were locally optimizing without maximally optimizing. So again, it's about thinking as humans, as designers, as engineers, and as people who are creating these systems about what the base rules are. And if we're careful about those base rules and we put those limits of don't harm on the front end, then I think we'll be okay.
Okay. Question here, please.
Hello. I'm wondering about terrorist activity who don't want to go with any of the rules that the West has, or even seem to operate under any other religious or philosophical rules. So how do you control that when they get hold of robots?
Well, I guess, like any technology, whether it's nuclear technology or AI or other technologies, it will fall into hands that are negative. I mean, we look right now at computer viruses that are used to attack systems. We look at things like that, and that already happens. So we will also have to be vigilant and aware that robots can be used in a negative way, and prepared to respond to that. But I think that also means when we design systems that we should put in very strong safeguards so that they cannot be used in negative ways. It's just, responsibility that we would have just like for any other powerful technology that we create.
There's a question here.
Hello. There's a very interesting documentary entitled Humans Need Not Apply, and it talks about robots in the job industry. And what is your thoughts on the future of robots in the job industry, and I guess also humans in the job industry?
Yeah, it's an important question, especially for someone who's done a lot of work with General Motors. So here's what I think. the jobs that, certainly in the short term, in the next 20 years, that robots will replace people with are jobs that would be automated anyways. I mean, we used to have a lot of people typing up and reproducing documents, right? Before we had Word, and we basically could reproduce documents very quickly. The computer system has actually changed work already. And even before you go to that, the Industrial Revolution changed a lot of jobs as well. What happened is, yeah, there was a short-term pain where people who were doing those very repetitive things were displaced, but there was also the creation of a whole class of new work. People creating, in the Industrial Revolution, all the new machines, the new trade that went along with that. If you look at the computing, we used to have lots of computer programmers and software developers, and now we can't have enough, right? You know, so work shifts to match the technology. The technology change is going to happen. It's like you can't hold back that flood. That's what's going to happen. What we can do is train and create opportunities for people to go with that technology to be able to develop it. So I see lots of opportunities for people who know how to program robots, who know how to deploy them, who can use Maker and Open to create new robots and new opportunities. So I think it's a work shift rather than a work elimination.
Yeah, I think we are coming toward the end. There's one question that is very popular. So it has to do with miniaturization is an ongoing quest. And related to that is a question around, so I know that many of our prospective students that are visiting us here today are interested in studying biomedical engineering and robotic-assisted surgery, or robots that will go in the body and go and do good things. How far is this going to go in terms of where you see robotics going on the miniaturization side?
Okay, that's a pretty, it's a pretty interesting area. So the intersection between robotics and biomedical and the opportunities there are incredible. I was just talking to students earlier today about technology that allows you to put in tiny little, basically robotic devices into the human body and be able to, you know, go right to the site of a cancer or to an embolism or something like that and treat it right inside the body without cutting people open. I mean, it already exists with Da Vinci and other technologies, but miniaturization is going to allow us to treat disease right at the source, and I think that's quite exciting and quite wonderful. On the other hand, there's also some great challenges, and I don't believe that there's anytime soon I'm going to have nanobots running through my bloodstream or something like that. But I do think that we will be able to use the combination of systems on a chip, micro-nano devices, along with the delivery of new materials and new drugs to the human body to help to cure diseases and make great advancements there. So that interaction between robotics, devices, biomedical and disease treatment is kind of one of these exciting new frontiers that I'm really excited to see what happens there. It's going to be very, very cool.
Okay, that's great. Ladies and gentlemen, if you will join me now in thanking Elizabeth for a fascinating presentation this afternoon.